Our third and last keynote speaker for this venue is Dr. Pijush Samui, Professor in National Institute of Technology, Patna. His presentation is titled Hybrid Artificial Intelligence in Civil Infrastructure. I request Dr. Siddeshwar, Assistant Professor, Department of Chemistry, to give a brief introduction of Dr. Pijush. Sir.
Thank you, Usha Madam. I, Dr. Siddeshwara DMK. It's my immense pleasure to introduce keynote speaker Dr. Pijush Samui. Dr. Pijush Samui is a professor in the Department of Civil Engineering at NIT Patna, India, and an adjunct professor at Ton Duc Thang University in Ho Chi Minh City, Vietnam. He received his PhD in Geotechnical Engineering from the Indian Institute of Science, Bangalore in 2008. His research interests include geohazards, earthquake geotechnical engineering, concrete technology, pile foundation and slope stability, and application of AI in civil engineering. He has published more than 21 books, 32 book chapters, and over 200 research papers in high impact factor journals, as well as 30 conference proceedings. We are privileged to have you for conference as a keynote speaker for our third session. Over to you, sir.
Very good afternoon to everybody. And myself, Pijush Samui, already given the introduction. So next 40 minutes I'll try to give some idea about the application of AI in civil engineering field. So how we can solve various type of problem in the civil engineering issue. So in the today the outline actually why actually we need the artificial intelligence, because if you go back to 20 years back, generally people criticize about the AI using. But nowadays it is using in every aspect of the life. And then some of the concept of the hybrid model. That is concept of the hybrid model. And then I will discuss about some of the sample applications of the AI model, and then we come back to the concept of big data, and then some conclusion what we can take in the home. So in Holding 1978, he has given some graph actually for the data and understanding. So if you look at this table, he divided that in this graph in 4 parts. Generally, region 1 is a good data and little understanding, and in this case, the statistics is the appropriate tool. So actually, we similarly generally don't deal with the region 1, and region 3 is a good data and good understanding. That means it's actually not a problem. It's so much not a problem, because if you have a good data and good understanding, and region 4 and region 2. Generally, we deal with this civil engineering aspect, because as we know that getting the civil data is very difficult, and it's quite costly also, and as we are developing countries, so it's very difficult to get the data. So generally we deal with the limited data and limited with this region 2 and region 4. So if we come back to the region 2, then it's okay, actually limited data and good understanding, but that is not the actual case. Actual case, if you have a very less amount of data, then obviously it will be not good understanding. We require more data things. So generally we deal with the civil engineering point of view, region 4, limited data and limited understanding. And here actually, AI is coming to the picture, because if you see that, for example, when you are going for any project geotechnical investigation, so if you tell the people or company that you do standard penetration test, air velocity or cone penetration test, he will not interested, because it's very costly. So generally we have to do it with a very limited amount of the data set and very little analytical. So AI is actually only solution for this region 4. So coming back to the AI, so what is the things AI involved actually? If you look at the see this part of the machine learning, pattern recognition and deep learning, fuzzy logic, expert system, swarm genetic algorithm. So these three under evolutionary algorithm and swarm intelligence and knowledge-based system, It is generally useful for the statistical modeling. So that is not a very all over the AI. Actually, it's a part of the AI. So I will discuss about some of the application in civil engineering, and recently deep learning is very useful for the civil engineering problem also. I will come back to the deep learning also. Now coming back to this machine learning AI, if you look at that AI actually basically ability to machine initiating intelligent human behavior. That means it's basically mimicking human behavior. For example, I am giving a simple example that, for example, your child, if you are learning a child that this is a mobile phone, this is TV, this is biscuit, then if you show similar type of things, you will tell that it is a mobile phone or it is a biscuit or it is a water bottle. But he does not know why it is mobile phone, why it is laptop, what is the water bottle. So AI generally is a initiator human behavior, and if you come to the machine learning, that is it's a application of AI that will learn from the experience also. That will learn from the experience means, for example, if you have some data set, I am telling you, in geological point of view, we have a certain percentage. So based on that, if you want to calculate the soil liquefaction potential, so based on the experience, for example, what we can tell, if the speed value increase, then the chances of liquefaction will be less. So that is actually based on the experience. So they have taken this concept also, generally their behavior. And third one is very useful. Neural network is generally take the human brain, concept of human brain. And as for the deep learning, they use an ML also, and they use the complex algorithm also to train the model. So this is the more or less AI generally would deal with the civil engineering problem. Now coming to the if you make a difference between the traditional algorithm and what the machine learning approach. For example, as a civil engineer student, if somebody tell you how to calculate the bearing capacity of shallow foundation, generally we will apply the Target simple equation. And if you put the value, and you will get the answer. So that is the traditional approach. Actually, is you give the data. That means you have to give the C5 of the soil, and it will give you the soil bearing capacity. But if you come to the machine learning approach, you have to go by the two phase. One is the training phase. That means you will use the training data set to train the model. Train means you are training a model. That means, for example, when you are training a children, the same type of things we are doing here. And then you show some of the other data set, and then the model will give you the prediction. So there is a difference between the traditional approach and the AI-based model. Now, if you look at this figure, so generally data set come from the which? There are two sources of the data set is there. One is about the accumulated data, and generally data set about the data from the documents, from the literature, and then data set will do the data processing. See, this is very important. Because you have to see that there is a lot of noisy data is there. For example, if you go for the in-situ testing, soil in-situ testing, there is a lot of noisy data will be available. SPT, competition data, noisy data. So you segregate this to reduction, then you do the normalization, and then you train by using your AI model. After training the model, you learn that how much you are, how is that you start in the algorithm, and then you configure the model. Now what you do, next you give the new input data onto this model, and if it is coming the good result, then that will give you the reliable model. But if it is not giving the good result, then again you train the machine learning algorithm. That is similar thing actually here also. For example, when you are learning a new subject, that if you not learn again, then you learn again actually. But same thing approach has been applied here also. So there are two types of algorithms generally available in the civil engineering field and deal with the civil engineering field. So there actually one is the supervised learning algorithm. Here actually your input and output is known. For example, I am giving a simple example. If you take a pipe foundation, so pipe foundation generally pipe capacity is our main concern, important factor, and that depends on the various parameters related to the pipe and the soil properties. That means in this data set, if you see that. This is the length of the pile and diameter of the pile, and this is the effective vertical stress, and this is the unhinged stress. So, and this is the pile capacity. That means here the input and output is totally fully defined. So that is called the supervised learning algorithm. That means output is known to us. So in this case, in supervised algorithm, so first you in step 1, you train the model, and then you develop the model, and then you after the raw data, that means for that what you want actually output of the pi capacity, then you put into the raw data that will give you the output. The problem is some of the supervised learning algorithm is the random forest is one of the algorithm. In this case, actually, random forest generally they have used the decision trees, and each tree is generally hierarchy of the decision, which is divide sample into 2 groups depending on the values of the single feature at a time. So what is the advantage is that less susceptible to the noise, that means it can deal to the noisy data set very well. And second of all, can handle a large number of training samples, and it can handle the large number of training samples also. So what is the disadvantage is that generally in random forest, actually we generally use the decision trees all output, and then we make the average. So ultimately what will happen if you take the average, it's very difficult to interpret the result. That means we will not know about what is the physical system of the how is the physically occurring. And what is the another disadvantage is that that slower than the other testing thing. But that will be not the in modern days we have very sophisticated computer. So I think this problem we can minimize. Second is the gradient listing, that is similar to the random forest, but in this case, training each tree actually sequentially done, and its advantage is that the study shows that it can handle, it can be more accurate. That means it can be more accurate than the random forest. And what is the disadvantage of this gradient boosting is that it is more challenging to tell the algorithm. Suborbital machine is one of the most useful technique, and scientists is using in every field of machine learning technique. It uses the kernel function to train the model, and here actually they use only some of the data set for the final prediction. And but what is the disadvantage is there? They generally it's a if you have a very large amount of data set, then its actually training will be more problematic, and it's a sensitive to the noisy data set. Another is a name-based model. It's a graphical model actually. It's a probabilistic lesson, and it's very simple to use, and it's a feature is important, easy to interpret. That means what your output is depends on which input, that you can easily determine by using the name-based model. And one of the disadvantages of this model is that assume that all features is independent from each other. For example, in this case, actually, what is the disadvantage is that they are assuming that each data is independent, but that is not the case. For example, if you take the soil parameter, there is always some relation between C, phi, and gamma. So that's why the name base has some problem when you are using for the geometrical field. Now, about the unsupervised learning algorithm, that their actually output is not known to us. That means, for example, if somebody will give you the data set of a particular place, and if you want to tell that whether soil will be liquefied or not liquefied, so there is no output here. So in this case, you put the raw data into the training, and then then by using the ML model, you can easily determine the weighted output. That means they are using some clustering technique. Here actually output is not known to us. So now, in this case, actually some of the unsupervised algorithms that K-means clustering that is actually used. Generally, what is the K-means clustering is that, for example, when you are using some of the data set, the data set will be influenced by the neighbor data. That means, if you use some data set and you calculate that what is the distance between the other data, and based on that you calculate the output. That is called the K-mean cluster. K-means means how many data you will use for the final prediction. Second one is the principal component analysis that is used. For example, if you take a landslide problem, landslide actually many of the parameter is there, depends on landslide. But by principal component analysis, we can reduce some of the, remove some of the parameter, because that has no effect, that is very less effect on the landslide. Another problem is that another model is that is the TSNE, that is a non-linear dimensionally reduction data, that is also just like a principal component analysis. But here actually disadvantage is that sensitivity to the hyperparameters and computational complexity. Now coming back to some application, that will be I think this is the theory I thought some of the application I would think about that. For example, if you take a slope failure, the slope actually depends on the, if you know that is the slope angle and height of the slope coefficient and unit of the soil and product coefficient and angle of internal friction. So these are the all input of a model, and the model output will be the slope will be stable or not fail. Now, if you look at those, there are two output in this case, that is the -1 and the +1. So input is this is the input beta 8, C, phi, gamma and phi. So if you look at that, this is the figure. You can construct many lines to classify the data set, but you cannot use so many lines for your final prediction. That will give you the lot of ambiguity and lot of confusion. So generally we have to use any of one of the lines, and the question is that, big question is that, which one will use for the final prediction? If you look at this figure, I try to explain that issue. For example, if you use this classifier, so what is the distance between this case? This is the boundary and this is the boundary. So in this case, this is actually your margin width. And if you use this classifier, and so this is your margin width. So if you apply your common sense, always if these two data is distance between the two data is higher, that will be good classifier. So generally, what is the SVM is doing? First thing, they are using the maximizing the margin. So that means you have to maximize the margin to get a good classifier. So now coming to the mathematical part. So this is the x and y, x is the input and y is the output, and this is a linear hyperplane. Just I have talked about that. That is W and V. So W is the weight and V is the bias. So these two, this is actually linear hyperplane. So if you now consider the plus plane and minus plane, then ultimately it will come this one. But actually in the civil engineering, we know that we have a lot of noisy data set. So generally we have to add some slack variable that is always greater than 0. So in the just few slides back, I have talked about the maximizing the margin width concept. So here actually if you look at that, we are using the margin width concept here. So this is the margin width coming. So if you want to maximize this margin, so that actually automatically comes to the minimization of this problem. That means if you want to minimize this term, automatically will be maximized. And with some error term on the error term, and that we multiply with the capacity factor, that is called that actually defines between that which will give the more weightage. So this actually you have to use given by the trial and error approach. So if you use more C value, that means you are giving the more weightage to the not terms. That means you are forcing the model to give a good result. And if you use the less error value, you are giving the more weightage to this term. So that means you are reducing the error here. Chances of reducing error is less. So that we have to that is a very difficult task in developing the SVM model. So this has to be done during the training of this SVM model. So as I have already told, the data set is required to develop the model. So we have collected the data set from all over the world, and around 32 data has been used, and so that out of 32, 23 has been used as training data set, remaining 9 data has been used as a testing data set. So after doing the MATLAB coding, then we have got a very nice equation. So that is the beauty of this AI model, is that it gives a straightforward equation. So S is equal to actually stability center for the slope, and sine is the signum function. That means if this value is greater than 0, this value bracket value, then it will give the +1, and if it will less than or equal to 0, then it will -1. So alpha is the Lagrange multiplier, so that value will get from this graph. So when I is equal to 1, you will get the first taking data set. So if you look at this alpha value will be around more than 29. So if you look at some of the value, alpha value has 0 also. That means that data has no effect on the final prediction, because alpha is 0, this equation will be, but that data set has no effect on the final prediction. So what is the interesting thing is that the remaining 15 data set and what we have collected, that has been applied in this equation. So only one data has been misclassified. So that means this model can be used for the final prediction. But what is the so this is actually general AI, we are talking about that, but has some limitation. So what is the limitation is that generally if you come nowadays, we are dealing with many data set. The big data concept is coming to the picture. In this case, there is a limitation of the optimization, classical optimization algorithm. So what is the classical optimization limitation is that it generally not give a good solution for a large problem. If the problem is very large, for example, if you use a very huge amount of the data set, generally it does not give a very good solution. So what we have to go for? We have to go for the hybrid ML model. So we do some meta-heuristic optimization and machine learning, that is called the hybrid. So meta-heuristic optimization, I will discuss about that. What is the meta-heuristic optimization next slide. So two things is very important when you are choosing an algorithm. So one thing is clear that you cannot tell this is a model you use for every problem. And another problem is that, so there is two type of question. One is that for a given type of problem, what is the best algorithm to use? And second question is that for a given algorithm, what kinds of problem can it solve? That means there is no guarantee that you use this model and it will give you the best result for all problems. That is actually problem. That is actually main problem when you use the AI. So you have to find out that what is the best model we can use for a particular problem. So nature-inspired meta-heuristic we generally use for this to solve the classical optimization problem. So what is the heuristic techniques? If you look at, generally heuristic are which seek a good solution at a reasonable cost, computational cost, without being able to guarantee either feasibility or optimality, or even many cases to check how close the particular solution is. So generally, why it is used, meta-heuristic optimization is used in this hybrid ML model. Generally, all AI model they want to do the error should be minimized. That means error should be zero. So ultimately, we know the solution. What is the solution? Our solution is that our error should be zero. But if you go by the classical optimization algorithm problem, that can give various minimum value. But in the meta-heuristic optimization, we know the ultimate solution what we want. Maybe that is mathematically not correct, but we know the solution error should be zero. So that's why meta-heuristic optimization has been useful for the larger problem. So what is the classification of the meta-heuristic optimization algorithm? That is the evolutionary algorithm, generally differential evolution, and a human-based algorithm, teaching learning-based algorithm, swarm intelligence, artificial ecology, Pijush algorithm, that is the gravity search, all these algorithms. Generally, we deal with all these algorithms for the hybrid ML model. Now, I will give you a simple example that how to use the hybrid AI model for determining one of the soil parameters. Is a compression index. I think everybody knows of the soil compression index. So I have taken the data set from a project in the Gujarat, that is on from this site, and there is around 700 object test data has been acquired from the LNP, and we got a data set about the compression index CC, and we got the other parameter also, that is the depth of the soil sample, gravel content, coarse sand content, medium sand content, fine sand content, total sand content, silt content, clay content, silt and clay content both, plug density, dye density, specific gravity, liquid limit, plastic limit. So these are all inputs of the model, and output is our compression index. So I have done some statistical analysis with what is the minimum value, average, maximum, standard error, standard deviation, kurtosis and Q-ness. So from that we can get an idea about that how our data is varying. So this is the project of the two hybrid model has been used. One is the ANN model, that is the neural network model, and this is ANFIS, Adaptive Neuropathy Information System. So here actually in the initialization of the first we initialize of the AI, then selection of the hyperparameter, and then you apply the generalization of the learning parameter, and then you here actually use the meta-heuristic optimization. So here the population size, maximum iteration, and set upper and lower bounds, random generation weight, train the algorithm, and then calculate the fitness function. That is actually I am telling about to get the zero value. And check the fitness. If it is yes, if it is with the stopping criteria, then yes, then you go to the optimal learning parameter, and then you train and test the ANN model, and we get the ultimate what is the optimized ANN model. Similar things can be applied square error should be close to 0. That means that is our main aim. So this is the data procedure model development. So I have used around 80% as a training data set and testing data set. So this is various optimization algorithm has been used. That is the ANPSO, particle sum optimization, and the B colony, Mount Glen. This is all optimization algorithm has been used. And then after developing the model, we should do some performance of the parameter. That means how the model is performing. This is some of the parameter I have calculated. That is the coefficient of determination, PI, Pijush index, mean absolute error, root mean square error. So these are some ideal value. So if the model is close to this ideal value, then you will tell the model is good. So now actually one problem will happen actually in this case. So further will some of the model what will happen? Maybe it is very close to this here, but it's very bad value in this case. So how we decide that which model is the best? So based on that, we have calculated some score analysis. What is the score analysis? For example, if you take that, I am telling you that we have a around 9 model. So R square, if you take the R square, so R square, for a good model, the R square value should be close to 1. So if you look at the R square value, so generally if you look at, so which is very close to the 1, so if you do the last one is very close to 1, so that will give you the maximum score. That means out of we are giving the 9 here, because we have a 9 model, so I have given the 9 here. Next is your 0.9159, so we are giving the 8. And last one, if you see that 0.6863, we are giving the 1. So for each parameter, you try to give the score in this way, and then you calculate what is the maximum score for each model. So if you get some maximum score here, actually in this case we are getting the gray wolf optimization ANA, that is given the 80. So in this case, this is the best model for the training case because it is given the maximum score. Next is the ANFIS, this is testing performance. Here also if you see that ANN gray wolf optimization is giving the maximum score. So in this case, the model is this model is a better model than the other all model. So this is the ANFIS case. ANFIS case here also we have done the score analysis and we have got this 80 data set, 80 total score, and this is the testing performance here also ANFIS PSO is giving the better result than the all other model here 80 score. So now after developing the model, now we have done some experimental validation also. So what we have done actually, we have done some tests in our laboratory at NIT Patna, and around 30 data we have generated, and this data we will use for the verification. Now the model has been developed, and we will use the data set for the verification. So these are the all parameters, and these are statistical parameters, and this is the compression index. So in this case, if you look at that. I have developed the actual versus. So if you see that the ANN they could actually give the best result. So this is the experimental and this is the data of experimental value in the x-axis and the weighted value in the y-axis. So if you look at that, more or less it's giving the quite close to the weighted value. But here actually one thing is that here the difference is more. So but ultimately we get some trend that its trend is quite good for both the model. And so this model can be used for the prediction of the compression index. Now I have done the monotonicity analysis also. Monotonicity means we have actually the output parameter is our compression index. So that means how depends on the other parameter. Because we have no idea about that. If we change the other parameter, that CC value how depends on the other parameter. So if you look at this, there is a very clear cut, some of the parameter is there, sometimes it is increasing, sometimes it is decreasing, but some of the cases we are not getting very clear trend. First of all, if you take that, this is the silt content, we are not getting very clear cut relation between the compression index and this one. So from that we can get an idea about that, how this compression index has been changed with this input value. So now I have talked about the deep learning. So how deep learning can be used actually for this various aspect of the construction industry. One is the feature expression. That is the generally this is the all features. The building dimensions, number of windows. This is the all features. And based on that, how to classify, image classification. For example, in a site, there are various people will be there. So there will be 75% of the construction worker, 95% of the engineer, 5% of the architect, and 5% of the fireman. So based on the deep learning, based on the image, we can classify that how many type of construction people are there. This is the image captioning, which type of image is there. Second is the activity recognition. That means what type of activity is going on. That means it's the digging of the soil. Object orientations, data orientations, and the object tracking. Even we can use the object tracking also by using this deep learning network. Second is the very useful in the smart city problem also. For example, we actually, as you know that we are going for the smart city project, and I am not going to the smart city details, but why we can use the smart city project. For example, if tomorrow the big rainfall will be there in the city, so that if we can predict the rainfall early, and based on that, by using the AI system, we can take a decision that what management is required for our drainage purpose and everything, so that we can manage the city proper way. So AI will be very useful in the smart city project also, and it is published in the GOD paper in 2017. Next is the smart building, because if you see that nowadays in the ordinary building, we don't have anything about the quality maintenance. Not even sensor also. But if we can put some sensor, for example, smart sensor control devices, building security, surveillance, smart HPC, smart energy control management systems, then this data set, if you use the AI system, and based on that we can develop a model, and based on that we can take a decision that, for example, if tomorrow is a power cut is there for whole day, so how we can maintain the everything, lift system or everything by using AI, that will be also very useful. Secondly, the monitoring of the infrastructure, that is very useful, because if you see that, if you go by the bridges, because railway bridges, that has been developed almost 100 years back, because there are no monitoring system. But what we can do, if we put some sensor there in the bridge system, and that sensor can take some of the parameters, temperature, moisture content, corrosion rate, all these things, and then you would transfer the data into the AI-based system, and after doing the analysis, then we can easily measure the condition of this building as well as bridges, and that then we can what type of protection is required, that can be used for the aging management also, because as the age increase, everything is deteriorating, whether building or bridges, every civil structure. So in the AI in the construction also is very useful. Smart robotics is AI-based smart robotics is coming to the pictures. There's cloud VR, that is the virtual regulation and augmented regulations, and artificial is IoT-based system. And similarly, the digital twins, if you use some, for example, in the building information modeling, if you use the building as a database system, for example, each database, for example, you take a building in the database system, what is the length of the building, what is the staircase, you take a database system, and based on the AI system, you can use the virtual building also. 4D printing is very important. Just I am talking about the 4D printing, because 3D printing we know. 4D printing means we add a term, that is the time value. That means, for example, after 10 years, what is the building condition? If that we can estimate from the building itself, then we can take a precaution also. And blockchain by using building information model. So this is the AI techniques have been used to very construction industry. So now coming back to the, I think we are moving to the big data concept. So for example, big data is actually, what is big data? We have to understand first. There is a four V's there. One is the high volume, high variety, high veracity, and high velocity. For example, I am giving a simple example that if you take an institute technique, for example, configuration test. For example, today also there is some in the world, some configuration test is going on. So if you can collect the data set, it will be huge amount of the data set, and in every day it will be changed. For example, it will be not a constant data set, because tomorrow also there will be again data set will come. So how we deal with the velocity, that is speaking of the data set. Every day it will be new data will come into the picture. That means whatever correlation is there, for example, we have a correlation using SPT versus high angle of internal fixation. That will change. So how we deal with this problem that is coming to the big data concept. And recently in Portuguese one scientists they have published one paper that is the big data concept to predict the magnitude of the earthquake. Similarly here also we know that how to use the data construction waste. Construction waste is a huge amount of waste generally generating. So they have developed one system, that is the one graph-based system, Neo 4G model. That is the one graph-based system. Using this graph, they take the all data set in the graph, and based on that, they are taking some decision. So what we can take in home, actually, I will end the conclusion actually. The first thing is very important. The performance in AI is very data specific. That means you cannot take this is the best model you use for the all problem. So you have to check that which model will give you the particular problem. Second point is also very important. The result of AI should be analyzed thoroughly and decision should be taken based on the practical experience. That means you cannot use the AI result 100% blindly, and that means you have to use your own judgment also. But one thing is very sure, last conclusion is very important. AI model can reduce the cost of the project. That is very useful because, for example, if we do one psychiatric study, for example, and if you do some SPV test, we cannot test each and every point. But if you do some of that, for example, we are doing some 10-point test, and based on that, we try to develop a map of the soil profile of the particular place. That will give an idea about what is the soil condition is there, and which type of foundation we can place into this soil. So by using this, AI model can use the cost of the project. I am giving a small example for the geotechnical point of view. Maybe it can be applicable to the structural and environmental point of view. Some of the book I have published, this is actually recently, this book is very useful for the big data concept, and this is actually all AI model has been given on all this in this book. And this is my Amazon author profile. And thank you, thanks, and questions are welcome.
Questions? Any questions? Thank you, Dr. Pijush. The session was truly effective. I request Dr. Vishwanath, HOD Department of Chemistry, to felicitate Dr. Pijush.